All right, we're going to start again. I apologize for the mistake. I forgot to turn off my speakers. Otherwise, my speakers play what you're hearing, and then you hear it again and again and again in an endless loop. And it just gets worse every time it plays. So, again, you should be here on todaysmeet.com/Perla Science. Once you're on, we'll be able to see you guys in our class. So if I could have our science people go ahead. Hakeem, can you take this one for now? And Logan, can you grab the other one? Hakeem, you might have to log this one right there. Okay, once you're logged into todaysmeet.com and you've entered a nickname, go ahead and let me know that you're here by putting in a message. So you'll be able to see your message up here. So I'll let you know that I'm here. So you can tell me and let me know that Mrs. Richards' class is here, Mrs. Taylor's class is here, and that way we'll know that everyone's online. So go ahead and type in a quick message. We'll wait for a second, and then we'll get started once we see everybody on today's meet. Now you're going to find there's some weird pauses in this while we do this, and that's because there is a 30 to 45 second delay in the streaming. So usually if I ask a question, there's going to be a weird pause where we're sitting here waiting for 45 seconds for them to do what we've asked them to do. So Mrs. Richards' class is there. We'll wait for Mrs. Taylor's class, and then once we see her message, then we'll be ready to go, and I'll explain to you how we're going to use today's meet. Yeah, just take it to your table for now. And then type in a message, Hakeem. Mr. Perla's class is here.
We're gonna be on YouTube.
You're working? So we're just waiting a few seconds. Okay. All right. So it looks like we have everyone. So this is how today's meet is going to work. You can put the computers wherever you want. Typically, I allow mine to kind of float around based on the groups that are on task. Today's meet we use so that the classrooms can ask each other questions. So let's say, for example, in my classroom we're doing something and we can't figure something out. A group might have this question and say, all right, we don't know how to do this. If no one else in the classroom can help you, you put it on today's meet and you would say, how come parallel circuits have to have more than one path, or something like that. And then the rest of the classrooms, if any group knows the answer, you would type in the response. If we don't know the answer, then I might stop what I'm doing, stop and address that issue so that we can talk about it and make sure that everyone understands what's happening. So typically, let's say in my classroom I have a variety of groups. So in my classroom I have broken up into 7 different groups. I've got groups 1 and 2, 3 and 4, 5, 6, and 7. Now, Logan, raise your hand so we can see that you have the Chromebook. And Hakeem, can't really see you, but we'll turn the camera here so we can see you. Raise your hand so we know you've got the laptop or the Chromebooks. And so the Chromebooks will rotate. They'll move around throughout the classroom. So if you're in groups 1 or 2 and you have a question that you need to put on the Chromebook, you would have to go to the Chromebook. Okay? You'd have to pick one person to go to the Chromebook. Now, the person that you pick has to be someone that's on task. So let's say in this group right here, you guys are working and someone has a question and nobody can answer it. Okay? And Jason, you guys might let Jason say, Jason, go type it in. So Jason goes and types it in on the Chromebook. Now, let's say in this group, Braden's part of the group and he's not on task, he's not helping with anything, and you have a question and he wants to be the first one to go to the Chromebook, he doesn't get to do it. Okay? It has to be someone who's part of the group that's participating, because then you're going to be able to word the question correctly, right? Because you're there. You're there, you're struggling, you couldn't figure it out, and you know what the question is. If you weren't on task, you really don't know what the question is. Okay? So make sure that you're on task, otherwise you don't get to type it in. About halfway through the class, we'd say at about 3:20 or so, the Chromebooks will rotate from those tables to these 2 tables over here. And then the people from the other tables have to come up. Okay? All right, so with that being said, let's go ahead and get started. The materials that you're going to need today, if you haven't pulled those out, you're going to need your basic science materials. I believe everyone already has them. This is basically what you need. You need a cell, light bulb, motor, wires, cell holder, switch, and your circuit base. Okay? If you don't have all these materials, you can have someone just kind of pulling them out. We may not necessarily use them all at once, but we are just going to very quickly go through and make sure that we understand what it is that we're doing with them. Okay? All right, so the very first thing that we're going to do is we're going to have science helpers in my classroom. I'm going to have you head on up to the science materials table, and you're going to go grab one of each and take these back to your table. So you're going to grab one switch, one cell holder, one circuit base, one light bulb, one cell, and a couple of wires. You can get 3 or 4 wires. That should work. So, science helpers, or I'm sorry, get her ones. Go ahead and grab your stuff. Okay, while we're waiting, if anyone from Mrs. Taylor's or Mrs. Richards' class has any questions about stuff that you guys have been doing, we're going to go back and we're going to review series circuits, parallel circuits, look at the differences between them, make sure that we understand them before we move on to the next part. Mr. Perla's room. Jason Butter. Oh, okay, perfect. Thank you. Mr. Jason, you're leading.
Mr. Perla, I have to use a finger high. Lovely. No, not right now.
Okay. Then stay with your boots unless you have to.
I need my mother's here.
Okay. All right, so again, if you are from Ms. Richards' class, if you have any questions about series or parallel circuits, we're going to explore those really quickly right now. We're going to go pretty quick, and so we'll come back to it and talk about this in just a second. All right, so the first thing I want to do is I want to take a look. Well, I'm going to go to my table of contents here and see where I have information on series circuits. Now, series circuits I had on page 8, so I'm going to go to my science notebook here and see what I've got. So here I've got some notes on parallel circuits and series circuits. So here what we basically did is we reviewed what a series circuit was. Okay, so what we're doing is reviewing what a series circuit is. And what you have in a series circuit, one of the things that we talked about that was key was that the fact that a series circuit has how many paths, guys?
One.
Just one. In other words, the electricity leaves the negative side of the cell. It flows towards the bulb. It goes through the bulb, back towards the next bulb, through that bulb, and back into the cell. The other thing that was really important for us to make sure we understand and remember is that electricity travels from the negative side of the cell to the positive side of the cell. Okay, so electricity always has to go in this direction. Okay, electricity will never leave the positive side of the cell. It always has to go from the negative side to the positive side. Now, how do I know which is which? Can anyone here tell me which is which? Serenity, can you come up and under the camera here show us which is which on this cell? So how do I know which is positive and which one's negative?
You can tell by the positive because which side's positive.
Hold it up a little bit. Hold it like closer to the camera. Okay.
Because there's a little part that's sticking out, and then the negative is just flat.
Okay. So the negative typically is the flat side. The positive has the little bump, and you can also tell because what's on the battery.
Plus and minus.
Yeah. If you look on on the battery, one of the sides will have that plus sign, and that tells you that that's the positive side. Okay. So that's a good way to tell on your cells which is the positive and which is the negative. Always look for the flat side. Now, there are some cells where both leads are right next to each other and they don't look that way. How many of you guys have ever seen a 9-volt battery? Those are the two rectangular and the two terminals are on the top. But if you look closely on the label of the paper that covers the cell, you're going to notice one of them is labeled plus, so you know which one's positive and which one's negative. Okay? So, coming back to it, we can look back on our notebook and we know that in a series, there's only one path, meaning the electricity can only travel one way. Okay, so if we don't have that connection all the way around, you're going to run into problems. So one thing that I could do when I have a circuit and I'm asking myself, is it a series circuit? One thing I could do is simply come in here and say, starting at the negative, okay, so this is where I start, I follow the path with my finger. So if there's only one way for my finger to get back to the cell, then I know I have a series circuit. If I can trace more than one path, then it's not a series circuit. Okay? Now, let's come down a little bit further. And we talked about cells in series. When you need to put more than one cell together, how does that work? Okay? Well, if you understand cells, and know that a cell has a positive and a negative, like this, okay, knowing that this is positive and this is negative, I have to understand how a cell works. So electricity comes out of which side?
Negative.
Negative. And it goes in
The positive.
to the positive. So if I were to take two cells, and I'm going to borrow one here for a second. If I were to take two cells and say, how are these two cells going to be hooked up? Well, what would happen if I hooked them up like this?
It won't work.
Why would it not work?
Because they would both push into different negative sides, but it wouldn't make sense.
Okay, so if I put those two cells like that, and I attempted to draw the electricity traveling between them, what I would discover is that the electricity would go this way, and that's it. Nothing happens. So what I have to do is I have to turn one of the cells so that the electricity comes out of this side, like this, and it wants to go into this side of that cell. So if I hook them up like this, if I were to hook them up like this, I'm going to have electricity leaving this side, going into the positive, and then it's going to go out of this negative, through the circuit, back into this positive. Okay, so that's how you hook up cells in series. Okay, so we're just kind of reviewing that because we talked about that. Okay, what happens if I don't hook them up right?
It won't work.
The circuit doesn't work. Okay, and that should seem very familiar to you because I think everyone at some point has encountered something like this, where you have a remote control. Oops, let me switch back to the desk now. Where you have a remote control, right? And what's inside the remote control?
Batteries.
Cells. Okay, in fact, if you look at this cell, it says on there it's a supercell.
Oh, God.
Okay, so they give it a fancy name, call it a supercell, make you want to buy them. Okay, but if I remove the cells, you'll notice that it's very specific. It's got these little springs, and it tells you how they have to be hooked up. If I put these cells in the wrong way, what happens? Okay, it's not going to work. So if I press any buttons, you don't see anything. Okay, now if I were to remove the cells and put them in the way they're supposed to go, okay, now if I press a button,
Oh, I know what that is.
okay, you'll actually see it working. Okay, so the cells have to be lined up correctly, otherwise it's not going to work. If you hook them up wrong, electricity will not move. And you see it all the time when with your remotes at home or toys or anything that you put cells into. Okay, so let's come back to our notebook here and keep going. So the question was, how can you light two bulbs brightly with one cell? Okay, so before we do that, let's go back to the series circuit and let's make sure that we understand how to do that. So I'm going to challenge you right now to build a circuit that has one path, has electricity, one cell, one path, and two bulbs. Okay, so in my classroom I'm going to have to get you more bulbs. But one path, two bulbs. Now we know that they're going to look, are they going to be bright?
No.
No, it's going to be dim. Okay, so right now, spend some time and build a circuit that has one path, two bulbs. Okay? All right, go for it.
Okay, so we need
You sell
And one thing doesn't have materials, right? Okay, you're all going to need an extra bulb, so go ahead and grab an extra bulb. And if you need extra wires, they're all up here. You don't need money, just bulbs.
Wait, we're not gonna. I don't think we're gonna use it.
It's 3:15 right now. We're going to wait about 3 to 4 minutes to build a circuit, so we'll come back. I'm going to mute
Okay, so
for a second so that it's not too loud in the class.
negative.
We're gonna go about 1 more minute on building circuits. Alright, time's up. If you don't have your circuit, that's okay. Okay, if you don't have your circuit, that's okay, but go ahead and get your eyes up here so that you can very quickly see what that looks like. We're going to have a group that's going to come up and share how they did theirs. So if you could come up and just show us how you hooked yours up, and then show us how it's one path. Yes, I do. Does she need to come see you? Okay, I'll send her. Thank you. Miss Ellie? Mrs. Oglesby? Alright. So go ahead and walk us through how your circuit is set up.
So how our circuit is set up is we have our cell here hooked up, and then we would have wires hooked up to all of them. And then we have a switch here and 2 light bulbs. So then
Can you show us how it's one path for the electricity to get back to the cell?
it's one path because here's the negative side, and we hooked a wire here, and then it came here, and it would go to this first light bulb, go through the light bulb, and then go through the next one, and then go to the last one, and then go back to the positive.
Okay. So is there only one path for the electricity to travel?
What?
Is there only one path for the electricity to travel?
Yes.
Okay. So one path, therefore this circuit is
Series.
Very good. All right. Thank you, guys. Oh, excuse me. All right. So that was a quick review of a series circuit. How many of you were able to build a series circuit? Okay. Were there any tables that weren't able to build it? Okay. Now, what challenges did you run into?
Well, I guess we did it the right way, it just won't work.
If it's not working, a couple things. Either the cell is dead, or you have to check all your contact points and make sure the contact points are working. Sometimes the bulb may not be screwed in all the way, and it's not touching the bottom. If it's not touching the bottom, then you don't have contact. It won't work. Okay. So if you have a circuit that's not working, you might want to double check and make sure the bulbs are touching the bottom, that the bulbs are touching the side. Another thing that you've got to be very careful of, sometimes with the bulbs, is, can I borrow one of your bulbs?
Yeah.
Okay. Show something. Another thing that you really want to be careful of is that sometimes you got to pay very close attention to the way this is hooked up. Oh, let me go to my desk cam. Okay, if you look carefully here, what you have is this metal piece here is attached to the switch, or to this bulb holder. Part of the problem is when I put this metal, you're going to notice there's this little metal piece here, right here, that I'm touching with the pencil. Okay, the spring actually has to be touched to it, has to be touching that, so that there's contact. Okay, so if the spring were to be in, let me show you. So let's say, for example, the spring were in like this. Is the metal spring touching the metal clamp? So I don't know if you can see it. Let's see. Okay, is the metal spring touching that metal part at the bottom?
No.
You're going to notice it's not. Since it's not, electricity won't travel. So you got to be very careful and make sure that your spring is actually wrapped around it. Okay, can you see? I don't know if you can see that, but you should be able to see how the spring is actually around the metal part down here. So double check that if it's not working. Over here, it's barely touching, so I might actually turn this and try to get it to touch a little more. And then you want to make sure the bulb is touching on the bottom and it's touching on the side. Okay, so if it's not, double check that. The bulbs are pretty hard to do. Okay, is there any other group here that wasn't able to get theirs to work? Okay, so yours, you weren't able to get it to work. Okay? Okay, if you can't get it to work, one thing you could do is test your bulbs one at a time by saying, okay, I'm going to do this. That lights that one bulb, right? If I put it here. Okay, so it lights, but barely. So what does that tell me? It tells me this cell is very close to being dead. Okay, so we'll switch it up.
Ours don't even light that much.
Okay, so if you were not able to get it, test one bulb at a time by just connecting a cell to one bulb. Okay, so this now works better. Now you can actually build your circuit. Okay. Close room. Okay, thank you. Bye. So again, if you're having trouble with your circuit, take a cell. Let's make sure that the cell is not dead. Hook it up.
Mr. Perla.
Hook up your cell. And then take a bulb and put it on the other end of this. If the bulb turns on, the cell's fine. If the bulb does not turn on, make sure that the bulb is sitting correctly. And if it still doesn't turn on, then you probably got a dead cell. Okay. Alright. Alright, so now that you've got a series circuit to work, now the question is, can you build another one that has more than one path for the electricity? In other words, it's going to the bulbs at the same time. So when the electricity comes out of the negative side of the cell, it's going to two bulbs at the same time. It's not going to one bulb first and then another. It's going to two different bulbs at exactly the same time. So we would call that a parallel circuit, because parallel means that you're going to the same place at the same time. Okay? So when you look at parallel roads, both roads go north or both roads go south. When we get to geometry, you'll understand what parallel means. And then when you connect it to science, you'll be like, that's why they call it a parallel circuit. Because it's two circuits that are doing exactly the same thing at the same time. Okay? So, can you light two cells, or two bulbs, brightly with only one cell? So the key to that is to build a circuit where the electricity is going to both bulbs at the same time. Okay, so take about 5 minutes to do that. We're going to end in about 10.
White one, and then we do it again.
Hold on, let's not do the original idea. Let's do the phone where you take it. That's not parallel. Yeah, one way. Oh, yeah. It's smaller.
So you need a switch that turns both of them on and off. Bulbs can't be almost dead. They're either dead or not. Let's see. Got your cell here. So let's test it. Let's put some wires on this cell.
Good. I punched one out.
Very easy to blame. Very easy to equipment. In reality, we didn't have to do it. So we always want to test to make sure that everything that could be wrong is checked. And then after we checked everything and we're like, okay, we checked the bulb, we checked the connection, we checked everything, it's still not working. Then you can say, okay, definitely it's got to be wrong with the bulb. It's either the bulb or something else. But it's working now. So can you figure out a way to light both of these brightly at the same time. Okay, so I want more than one path. Are you watching? Can you put a switch in there? Turn them both on and off? Once you do that, now you've got a series. Hold on.
It's like
So I don't have to. Well, that's, yeah, as soon as you do that,
Not funny. I know what this is.
Well, you're not, right? Well, we already said, anyone that is disrespectful to another person, it's a $50 disrespect citation. So if you start handing those out, it'll stop. Alright, about 1 more minute, guys. Okay, can you put a switch to turn the bolt on? Nope. Well, if he's got a circuit that's working, and he's got time to do the motor.
Don't worry. We are so we need other lines.
Perfect. So how does this work? The electricity comes out here. If the switch is on, it'll go through. If the switch is off, it doesn't work. Now once you turn it on, it splits into both poles, and then comes back. So that's exactly it.
We need to touch this switch.
Okay. Alright. Time is up. Alright, so let's stop. We've got only a few minutes left before we stop. So all materials down. Okay, make sure if you've got something going that you unplug it or you hit the switch to make sure it's off. Because we don't want the cells draining while we're doing this. So if you have a circuit, make sure it's off while we talk about this. Okay, so how many teams got it to work? Okay, let's take a look at today's meet real quick and make sure that there are no questions. One of the questions was motors. Do you have to use the motor? Motor does not have to be a part of the circuit, but you can add it if you understand how to do it. The problem is once you add a motor to the circuit, it's one more device that's drawing electricity, which means everything else is going to work less efficiently. So if you don't do it correctly, the motor is going to really drain the bulbs, and it'll really drain the cell. Okay. So the question is, how do we do this? How did we hook up these circuits so that we had the electricity going to 2 paths at once? Serenity, did your group get it to work? Mm-hmm. All right, can you guys bring your circuit up and show us how you did it? Oh my goodness. Mr. Perla's room.
Okay, turn it on, turn it on.
Okay, thanks.
I used to say use my strategy, but hey.
I think it's on mute.
Hey, Leah, Cameron is with Miss Ingrid. Okay, thank you, Mike. All right, go ahead. Show us how you did your circuit. Perla's room. Heath? Yep, he's heading. He's going. All right, thank you, Mike. Mr. Jackson, you going home?
So what we did was we took one of the wires and connected it to one side of the battery and not the battery, the bulb, and we did that same on each side.
Okay. So a little louder, can you now use your fingers to trace the paths that the electricity is taking?
So it goes from the negative side of the cell into the light bulb.
So how many paths are there?
2.
2. Can you use both fingers then to show us the 2 paths at the same time? Okay. Well, where does it start? So take your finger, start where the cell starts, and then follow the paths. Okay. So what you have is electricity coming out here, splitting, going 2 different directions back towards the positive, right?
Yep.
Okay, so you have 2 different paths, both drawing electricity from the cell at the exact same time, and that's why they're both bright instead of them having to share the electricity from each other. Okay, this is called a parallel circuit. Okay, all right, very good. Thank you, guys. All right, so hopefully what you've been able to see is that a parallel circuit is a circuit that has more than one path, which means that all the components that are in that circuit are getting electricity from the cell at the same time. They're not having to share the electricity with one another because the electricity is actually coming from the cell at exactly the same time as everybody else is getting. So what does that look like in terms of a picture? Well, if I came back to my notebook here and take a look at it, you're going to see that this here is a parallel circuit. The electricity comes out of the negative side of the cell, and it actually goes into 2 different directions. It goes towards this circuit, and it goes towards this circuit. And then it comes back to the positive side of the cell, because in order for it to be a circuit, the electricity has to end up where? In order for it to be a circuit, it has to end up?
It has to end up to the same place where it started.
To the same place where it started. Now, could it start off and end up at a different cell?
No.
No, it's got to end up at the exact same place it started. Okay? Otherwise, it's not a circuit. Okay? So, this is the picture you drew. This is how you would draw it as a picture. This is not the way it would normally be drawn. This is just a quick version. Later on, we're going to look at something called schematic diagrams, which is how it's actually drawn. And you're going to have electrical engineers and stuff. You'll actually see how they actually draw circuits. Because when you have curves and all that stuff, it makes it very confusing. They have very specific ways of drawing, and we'll look at what is called a schematic diagram, which explains to you exactly how you would draw the circuit from a science point of view. Okay? So the key for a parallel circuit is that there is more than one path. Okay? So here is another circuit. You're going to notice that it still has more than one path. You'll notice it comes out of the cell in one wire, but once it gets to this point here, you're going to notice it splits. Some of the electricity goes this way to that bulb, and some of it splits to that bulb. And so the best way to figure out whether a circuit is parallel or series is to follow the wires with your finger. If you notice that there are 2 wires and then electricity can go in 2 different directions, you've just found what kind of circuit? A parallel circuit. If your finger has to go one direction and you notice there's only one way for it to get back, then you found a series circuit. Okay? Here's another example of a parallel circuit. Okay? And you'll see, once again, electricity leaves the negative, goes to this bulb, but once it hits this bulb, some of it goes through the bulb, but the rest of the electricity will actually jump and go to the next bulb. And then it'll come back to the positive side. Okay? So there's lots and lots and lots of different ways to hook up a parallel circuit. The important thing is to be able to make sure that you can trace the path with your finger, and then if you see it split at any point in time, then that's where you found a parallel circuit. Okay? So that's going to do it for series and parallel circuits. Tomorrow we're going to get into a little bit more detail. We might review the string of lights, and then some of us might get to go to Miss Richards and Mrs. Taylor's class to help them build those circuits. Okay, so if you're from Miss Richards' class or Miss Taylor's class, thank you for joining us. We're going to sign out by saying goodbye to you guys. So, bye. And we'll see you guys tomorrow.
Goodbye.